finding 650 bugs, but the cost is not 65,000. The cost is 50,150, and that's because 150 of the bugs found by the test team were found at the cost of $1. Nice. So now we've got 900 bugs scrubbed out through requirements reviews, design reviews, unit testing, and formal system testing, and perhaps system integration testing, leaving only 100 bugs to go to the customer. So our overall defect removal effectiveness is 90%, which is pretty good. Not that it can't get better, but that's certainly a good number of bugs to find, and obviously a dramatic improvement over what was happening before from a delivered quality point of view. And notice that our cost of quality here, total cost of quality, is down to 235,000 and change, which is quite an improvement, especially considering that we're looking at $82,000 investment. So it's we saved over $500,000 on that $82,000 investment. So that's a 627% return on investment. So very nice. Now, we've been talking so far purely about must-fix bugs, but of course, not every bug that you find has to be fixed. So let's suppose that in addition to the 650 real bugs that we find another 650 that are not must-fix, that are deferrable. Remember, this is a hypothetical case here, but we're going to just assume that. So, some number of bugs often do get deferred. Whoops, pardon me. So you might be thinking, well, okay, we found bugs that didn't get fixed. I mean, why is that valuable? Where's the value in that? Well, pardon me, we're having a little technical difficulty here. The value in the bugs that don't get fixed is, I'm sorry, I'm having a little technical problem. Okay, get that back. The value in the bugs that don't get fixed is three dimensions, if you will. One is that you know where the bug is, and you can actually prevent the user from seeing the bug by basically walling off the buggy segment of the program, right, and make the part inaccessible. And that might be a possibility. If you don't want to do that or can't do that, then you can have release notes or errata sheets or something that say, hey, there's a known problem in this area of the code. Don't try doing this, or it won't work. Or maybe even better yet, you can provide a workaround. So if we can come up with a workaround, then hey, that's good. Now, one thing I want to point out here is we're putting a value on something, but we have to remember that this is relative. Must-fix bugs are much more valuable than non-must-fix bugs, and one of the things that we sometimes find in test teams is that they find a lot of trivial stuff early in the process and the more important stuff later, and that's a problem. You want to sequence your tests based on risk so that you're finding the really serious problems first. The other thing that's important too is you do have to recognize the difference between a must-fix and a non-must-fix bug, because if a bug is classified as not must-fix and you identify a workaround for it or something like that, but then the customer said, no, that's not okay, you have to fix that, then you're going to incur an external failure cost anyway. So a good cross-functional bug triage process should be in place to try to deal with this potential problem of misclassification of bugs. Okay, so how do we calculate the return on investment for a bug that doesn't get fixed? Well, the way that I have done this in the past is you talk to the help desk or tech support staff, and you find out what the average amount of time is for different kinds of calls. So, if for a known bug, assuming there's some knowledge base that they can access, a known bug, how much longer does that take, or how much shorter is that, than a call for an unknown bug? And then how many bugs how many support calls per bug on average, which also is something that should be extractable from the customer support databases. And then finally, what is the fully burdened hourly rate for a tech support person? So if we assume that this hypothetical that it takes 15 minutes less to deal with a call for a known bug versus unknown, and that each bug generates on average 5 calls to the support team, and that a support person costs on average $40 per hour in terms of their fully burdened staff costs, then each non-must-fix bug saves $50 when it's detected. Now, notice that this is just looking at the saved time for the workaround and that sort of thing. The preventing a user from seeing a problem or helping a user avoid a problem. I mean, they're not going to call up and say, oh, thanks for the help in avoiding that problem because I didn't have to call you today. So it's a little harder to quantify those elements, but certainly for the calls that can get disposed of more quickly, we can calculate some of the value of the non-must-fix bug. Okay, now notice that there is no increased cost for the to capture this information. And basically, we're already finding the non-must-fix bugs and documenting them, so the investment remains the same at $82,500. But what I've done here is I've calculated for using the $50 figure at the $650 or 650 bugs, found. Then we've got $32,500 as the value of those non-must-fix bugs. Now, I want to put that in comparison. Notice that in finding must-fix bugs, we delivered a net reduction in cost of quality of over $500,000, and for the non-must-fix, the value is only $32,500. So it's an entire order of magnitude less, more than an order of magnitude less. So, clearly focus on finding the must-fix bugs. The non-must-fix bugs are kind of, in a sense, almost loose change picked up off the table relative to the real hard value of the must-fix bugs. But there's more, as television ads used to say. Well, wait, there's more. So far, we've just been looking at the cost of cost associated with finding bugs. Now, the thing is that the testing is not just about finding bugs. Testing is also, in a sense, a form of insurance. It reduces something that risk management refers to as the cost of exposure. Specifically, it manages the risks associated with quality, which often do have financial consequences. So you think about, there's this economic concept of substitution for those of you who plodded through some economics courses in college like I did. It says that one way to quantify the value of something that's perhaps difficult to quantify is to look at the value of something else that serves as a substitute for it and see if you can quantify that. So basically, insurance is the more typical way of managing risk in the real world, and one which is subjected to the free market, and thus, it's very well established as to how one puts a value on insurance. So the way that the insurance companies establish what the price is that they need to charge for a insurance policy, which you could say is the actual value of it, right? The actual price charged, which would be above that, would be their profits. The way that the insurance companies do this is through use of what's called an expected payout. The expected payout is calculated by taking the probability of a loss and multiplying it times the cost of that loss. So let's say that you're selling car insurance and you know that 10% of your policy holders will have a claim in a year, and that the average claim will be $2,500. So you have to charge each policyholder at least $250 to meet your expected payout.